Hey guys, we are going to be working on graphing linear relationships today. So if you have your journal, we're going to be, let's see here, page 2, 3, 4. We're going to be on page 4 in the journal. If you're at home and you don't have the journal notes, you can also use the textbook. We're going to be on page 159. Since my copy is not as good, I'm just going to kind of start looking at what you're seeing on the screen instead of my paper. So this says, maps have grids to locate cities. The coordinate plane is the type of grid that is formed when two number lines intersect. Okay? These number lines are called axes. Okay? Your x-axis and your y-axis, which I'm sure most of you have heard. The number lines separate the coordinate plane into 4 regions called quadrants. So it kind of goes in a C position. So we start here, 1, 2, 3, 4, and you can see they actually label these with Roman numerals. Okay, 1, 2, 3, and 4. This 4 is created from that V, which is like 5, and the one behind it is like -1, so that's quadrant 4. An ordered pair is a pair of numbers such as 1, 2 used to locate or graph points on the coordinate plane. Okay, so when we have our ordered pair, we have two numbers here. The first number is the x-coordinate. This tells you how much to count either right or left from the origin. Okay. If it's positive, we go right. If it's negative, we go left. The second number tells us to go up or down from that point. If it's positive, up. If it's negative, left. Now, in your book, I already have this written in my journal. Right here, you can see it's pointing to the first number. So we call that the x-coordinate. So everybody on that line put x-coordinate. Okay, now down here, you can tell it's pointing to the second one, this one down here, the bottom line. So that's the y-coordinate. So I want you to write that in the blank. Y-coordinate. And then this line looks like it's pointing at the whole thing, so we're going to call that our ordered pair. Right there. Ordered because it's in order, x, y, pair because there's two numbers, okay? Then we have our origin right here, that's already labeled for us, okay? So, as we go down, it says graph points 2, 3, and -3, -2. So that's what we're going to do together first. So you can see I already have everything written here, and I know mine's a harder to see, but hopefully you can see well enough. So graph points 2, 3. So remember, we start here at the origin. The first number tells us left or right. In this case it's positive, so it's right. So I'm going to start right here, and I go 1, 2. And the second number is 3, and that's positive. It's going to tell me to go up. So I go over, 1, 2, up, 1, 2, 3, and I'm trying to make sure I'm right on that dot there. It's kind of hard even for me to see on my own paper. So, and normally we would label that like A or B or something, but it's not telling us what to label it. So this is just a little practice graphing. Okay. Now the next one is -3, 2. So again, remember we still start at the origin. The first number tells us left or right. In this case, it's left because it's negative. So we would say 1, 2, 3. Actually, physically make the jump. 1, 2, 3. And the second number is negative, which means down. So 1, 2, 3. And then 1, 2. And I can tell right there that's at -2, so Just trying to make sure because I'm having a little trouble seeing on my own paper. Okay, and so that's just how we graph. Now once we have our two lines, we could actually connect our lines to make something linear. Okay? Okay, so now we're going to do this problem, and it says the cost of 3 movie tickets is $12 for 1 ticket, $24 for 2 tickets, and $36 for 3 tickets. Determine whether the cost is proportional to the number of tickets by graphing the coordinate plane. So remember, for something to be proportional, write this down, pause it if you need to. For something to be proportional, we either need a constant rate of change, which means that it will be linear, and I feel like I spelled that with an extra letter in there, linear, but it also has to go through 0, 0, okay? 2 things have to be true, okay? If only one of them is true, it's not proportional, okay? So, let's look at our little graph here, what we notice about it. So, first of all, I see tickets. Second of all, I see cost, okay? So, these are actually points, okay? And it should be X, comma, Y, so tickets, comma, money. So, the first one is 1 ticket costs $12. Okay, so 1 ticket costs $12. Okay, then our next one says $24 for 2 tickets, but again we want X first, so 2 tickets cost $24. So remember, we start at the origin, count over 2, 1, 2, and we need to go up to 24. Notice these are nicely spaced out by 12s here, so 24. Okay, and the last one is 36 for 3 tickets. So how do you think we would write that? $3, 36, right? 3 tickets, $36. Okay, now what we want to do is, I can for sure tell this looks linear to me, right? When we're kind of tracing it. Now I want to see if it will go backwards to 0. So I'm going to just kind of follow my pattern backwards. It looks like it's going, and when I count this, I'm literally counting by ones. I'm not counting these numbers here. So, like, I would go back 1, down 2, back 1, down 2. So the next one would be back 1, down 2. And look where we end up, guys. We ended up at the origin. So what I notice is that it is linear, and it does go through 0, 0. So I want you to put proportional. Why? It is linear. I cannot write this word today for some reason. I'm wanting to put an extra letter in it. Linear, and goes through, and then right here you can put the origin, or you can put it goes through 0, 0. Okay? And that's it, guys. If it's straight and goes through 0, 0, then it's linear. Okay? And let's go in and find our constant rate of change so we can write our equation for it. Okay? So normally we have these in a table. 1, 2, 3, 12, 24, 36, and I don't know if you remember us doing this, right? Delta Y. So each time it goes up by 12, right? So our change in Y is 12, and our change and x is 1. So this is our constant rate of change. And not only is it our constant rate of change, it's also k. And it's k because it is proportional. So I can put 12 or 12 over 1. It literally is the exact same thing. So we are almost done with this problem, but I do want you to write, because I think this is important, y equals kx. Okay, it's k because it's proportional. We know what k is. It was 12. It was the same as the constant rate of change, 12x. And there is my equation. So I could actually put in any number of tickets. Like if you said 4 tickets, 12 times 4, that would be 48. That would go there. Okay. Okay. So what I want us to do, we're going to actually come down here and kind of take this from a different viewpoint. This time we're going to be given the equation. Okay? I can tell immediately this is not going to be proportional. Okay? I can tell because it has plus 3. Now, if you don't have this, I want you to just kind of draw a grid on your paper. Okay? So what I'm going to do is I'm going to show you how this equation relates to this graph. How this equation relates to points. Okay? So this is very much beginning algebra. Okay? And it can be a little intimidating because there's not a lot of information, but you can get your own information. So what we're going to do is we're going to make something called an XY table. Okay? Now, the thing about an XY table is we can choose our own values, the ones we want to use. And of course, I always like to use the ones that are the easiest. So I almost always use 0. I will usually use 3 to 4 numbers, 1 positive and 1 negative. Okay? Now, in this case, notice we kind of have something here that I would normally say is ugly because it's a fraction. But it's a half, so that's easy. So I'm going to choose x values that are easy to take half of. So I'm going to choose 2, because we can take half of 2, and 4, because we can take half of 4. And then I'm going to go in and throw in a negative in there. And we'll do negative 2. Okay? So you may have done this last year on some of they had something called Algebra Builders. So just watch my steps. See if you understand. If you don't understand the first time, maybe the second time. If not the second time, maybe the third time. Okay, again, I'm just making up these numbers. I know they'll fit on my graph. Okay, what is x first? X is 0. So I'm going to put it right there. Half times 0 plus 3. Now this one, I normally am going to show work, but this one I'm going to not do as much work because it's 0. What's half of 0? Well, anything times 0 is 0. 0 plus 3 is 3. And guys, that is your first point that I can graph on my number line. So now we're going to start again, but this time instead of 0, x is going to be 2. Half times 2 plus 3. So I'm just taking this equation, and each time I'm plugging in the x value. Okay, so here I'll show a little bit of work. What is half of 2? So half of 2 is 1, plus 3 is 4. Okay, now we do it again. Half of x. We already did this one, we already did this one, we're going to do 4. Half of 4 plus 3. Half of 4 is 2, plus 3 is 5. So you can probably see a little pattern developing here, right? I know we're going to mess it up here because of the negative 2. But now, all we have to do is graph our points. First point, 03